Welcome everyone. Thanks for joining us today for this session of STEM Community Lunchtime Conversations. My name is Jeremy Babender, and hosting with me today is Beth Nickel from Arizona Science Center. Today we are excited to talk with our presenters that will be sharing an overview of the Arizona Science and Engineering Fair, how the program works in the high school, and the amazing and impactful winning projects. Our presenters for this session are Beth Nickel, Chief Academic Officer at Arizona Science Center, Debbie Naipar, teacher at Hamilton High School, Bailey Tischer, student at AzSEF, Michelle Sheik, student at Arizona College Prep Erie, and Zena Zhao, student at Hamilton High School. Thank you all for joining us today to speak with this special group. Thank you, Beth, our co-host, and the Chief Academic Officer at Arizona Science Center to give a brief overview of the Arizona Science and Engineering Fair.
All right, thank you, Jeremy. I'm having a little bit of a technical issue here. Okay, all right, so each year since 2008, AzSEF has brought around together Arizona's most innovative students from across the state to showcase their imagination, innovation, and curiosity. And prior to COVID, AzSEF typically had about 1,000 students from across Arizona and 300 judges and volunteers to participate annually. However, this year, our numbers were a little bit smaller as students, teachers, and families had many other obstacles to overcome. We had 425 students from grades 5 through 12 to compete for top honors and prizes. This year was the first time ever that AzSEF was held virtually. Next slide. So why do we have science fairs? What is the importance of science fairs? You know, the types of things that students have to do as they are going through and devising their research question, putting together their experiment, conducting the experiment, doing the evaluation, doing the data analysis, et cetera, and drawing conclusions with their information. All of those skills that the students learn in that process are things that are going to help prepare them for their future moving forward. So whether it is, you know, continuing their skills and their learning as they move on out of high school and into those skills that they're going to need for positive and, job skills moving forward. So, and then, you know, finally, the work that they do during the getting prepared for the science fair, doing the research, et cetera, really provides students an opportunity to really learn deeply about something that they're interested in. Next slide. So in looking at the science fair system, so most students in the state of Arizona have multiple opportunities to earn their way to AzSEF. So as you can see, you can start with school level fairs, district level fairs, or regional fairs. And students who win first place at any one of those levels within the fair system can earn a spot at the Arizona Science and Engineering Fairs. Obviously, school fairs can be, you know, home schools, it can be public schools, private schools, et cetera. Our districts, again, obviously, our public school districts and charter school district organizations. And then our regional fairs include SARSEF, which is the Southern Arizona Region Science and Engineering Fair, the Northeastern Arizona Regional Science Fair, which is held up in Navajo County, and then our Youth Engineering Science Fair, or YES, which is in the southeastern part of Arizona. So any first place winner from any of those different spots, school, district, or regional fair, have the opportunity to make it to AzSEF. Then our best and fair winners from AzSEF earn an all expense paid trip or opportunity to participate in the Regeneron ISEF, which is the International Science and Engineering Fair. And again, this year, this ISEF is taking place virtually during the month of May. This year, we had 15 projects represented by 20 students that were awarded Best in Fair, and they will be competing with approximately 1,900 students from around the world in just a couple of weeks. Next slide. So in addition to our Best and Fair awards, we are very fortunate to have multiple opportunities for students to be recognized for the amazing work that they do. As you can see on this slide, Arizona students are recognized for their innovation both locally and nationally. We have with us today 3 of our AzSEF Best and Fair winners who will be representing Arizona at the Regeneron AzSEF, as well as Debbie Nipar, a science teacher from Hamilton High School. Hamilton's program is very robust and has produced many of our AzSEF finalists over the years. And at this time, I'm going to pass the microphone, I guess you would say, or the Zoom window over to Debbie so she can share about the program at Hamilton and how they have developed a culture of research. Debbie.
Hello. So I was invited to talk a little bit about what happens at Hamilton High School. So we opened in 1998, and I think part of our success is due to our first principal and his vision of Hamilton being a top science school. And we were kind of started that way from day one. And so that made it, that made the whole thing impossible, or contributed to it. Originally, students from every science class were expected to complete a science fair project or an independent research project. And we did that for many, many years. It has since it's since evolved to where only honors biology and honors chemistry classes are expected to do projects. And that was just because we had so many projects. We would literally have 500 projects for one school. And so we now we basically have 9th grade and 10th grade students that are primarily contributing to our projects from our school. And when we started doing this, we also developed AzSEF, which is a Hamilton Invitational Science and Engineering Fair, and that was our district fair, and that took place at our school. So we didn't have a district fair before that, so we developed this district fair. The vision for that fair was that we would have that whole day, a whole weekend. Sorry, that's our bell system. That's devoted to the celebration of science and technology. We had a whole Saturday blocked off. We invited vendors from around the valley to come promote their science-related programs. We had our projects set up in the gyms for grades 4 through 12 originally. I think we ended up going 5 through 12 at some point. Anyway, it was just this idea that we were going to have just to make a big deal out of science for a weekend. And then our winning projects from AzSEF would go on to AzSEF. And somewhere in the early 2000s, we decided that in order to really get to the next level, we need to have an independent science research class. And that class would be devoted to students who wanted to spend more time, maybe even years, on their project, and they would have that time if they just had a class devoted to that. So that's where our real success started. We had, within the first couple of years of instituting that class, we had students that were qualifying for AzSEF, and we've had those students qualifying every year since then, except for 2020. So it's been very successful in terms of generating winners and AzSEF finalists. I don't feel like that's the focus of the program. However, we always try to emphasize the fact that you're doing this research for the love of research, for your own growth, because you're researching something that you really are passionate about, and we approach it with a sky's the limit. You can research anything you want to type of mindset, and just winning a competition is like the icing on the cake, but it's not the goal. Sorry, my bell again. And then finally, and the pyramid that we try to build is that they will do research in the classroom freshman and sophomore year, and they can build on that in the honor science research class if they want to. And that has really built our longevity and our long-term success in the program. That's allowed students to become experts in their own field. And many students have gone on to research the same things in college. I frequently have students come back and present their college research. It's just been, it's worked out really well for us. And of course, we couldn't do it without the support of our administration and our community. And we just have amazing students that make it possible. So that's our program.
Cool. Thanks, Debbie, for providing the overview of that. And probably the, really giving it a sense. It's really awesome that you're able to create a whole class for students to, have less time and space to do research. That probably makes a huge impact.
Yep.
To be able to do that.
Very blessed.
So first, I wanted to cue our first student. We're really excited to have Bailey Tischer here from ASU SEAN to share her project titled Developing an Accurate Measurement Procedure to Determine Cell Permeability.
All right, thank you so much. My name is Bailey Tischer, and my project is based around just that, trying to find a way of measuring cell permeability that has not been done before. A way of measuring it not as a stagnant value, but as a consistently changing function over time with high accuracy by a nanosecond or microsecond. And the reason what cell permeability is it's the amount of pores open to a certain chemical in a cell at any given point at time. Different chemicals have different pore numbers and different amounts of which the cell will take to that chemical. And it becomes an issue, especially when there is very low permeability of certain chemicals like antibiotics, because a lot of them target intracellular processes and simply cannot get into that cell. And so finding ways of studying cell permeability, understanding it, finding ways to increase and decrease it is very important to the future of medical treatment, especially when it comes to dealing with a population with a lot of immune deficiencies due to COVID-19. So the issue here, however, is that you cannot simply just go in there and count the number of pores in the cell at any given point in time. They're simply too small, and it's not really feasible for an entire population. So I had to think a little bit outside the box. And the way that I did that was trying to find out perhaps the relationship between cell permeability and the rate at which the concentration of any chemicals entering the cells. And to determine this relationship, I used an antibiotic called vancomycin, which is just that, a chemical whose ability to enter a cell is reliant upon increased permeability. Now, I had a model, an equation model of the rate at which the vancomycin could enter the bacteria, modeled based off of the concentration of the amount of cells that were killed by vancomycin, based on the concentration of vancomycin at a given point in time, the amount of nutrients available, and the population at a given point in time. And with these three functions by which that factor was reliant upon, I deduced that permeability should play a role in that equation, since the amount of bacteria that are killed by the vancomycin is reliant on permeability. So I applied a stimulus in the form of electroporation onto the cells and determined precisely how that stimulus was affecting all three of these factors and how it might be affecting the function of CFT, the vancomycin concentration. As you can see right here on this graph, sorry, moving the box real quick. All right, you can see right here on this graph right there, we have the two most important factors, those being optical density, which is the equivalent of the amount of bacteria in the population at a given point in time, and the concentration of vancomycin in both groups. Now I had a control group that had no stimulus at all, and that is seen by the top graphs, that being the you can see right there, the vancomycin is entering at a very constant rate. However, when there was a stimulus that increased permeability number of pores to the vancomycin, it enters them very, very quickly. As you can see, it's decreasing from the solution very, very quickly, and more bacteria are killed as a result of that. And from this, I theorized that perhaps the constant amount of pores relates to the derivative, the slope of the vancomycin entering right there. As you can see, the slope is a constant form right there in that top graph where there was no stimulus applied when permeability was also constant. And so from this, I deduced that perhaps there's a direct relationship here. And so I theoretically created this model equation, C prime of t is equal to negative A times P of t, which essentially deduces C prime of t is the rate at which vancomycin is leaving the solution. A is 1 over the average time taken for vancomycin to enter cells, and P of t is the number of pores at any given point in time. And I applied this model, and I got these two graphs right here for either group. The first one being as it should, very constant, no stimulus applied. Second one also as it should be, as it starts at very high because measurement occurred after the stimulus was applied, and becoming down to 0 and being constant to its natural state after about 100 seconds. And I deduced this to be supportive of my data that this model is likely quite accurate when it comes to measuring cell permeability. And since the vancomycin concentration and its derivative as well as the constant of A can measure with very high accuracy by a nanosecond or microsecond using spectroscopy, then you could also find P of T by a nanosecond or microsecond using spectroscopy with very, very high accuracy. And I believe that is it. I finished a little bit early. I know I was talking a bit fast, but it is what it is.
All right. Well, thank you so much for giving us that overview of your project. And then we'll, if you're thinking about, from the audience, just think about some questions that you'd like to ask our presenters as they're going on. You can put it in the chat, or we can ask them afterwards as well. And so next, we're excited to cue Michelle Shake from Arizona College Prep, Erie, and she'll share a project titled The Novel Approach to Healing Burn Wound Infections Using Flavonoids, Exploring the Interaction Between Flavonoids and Antibiotics.
Hello, my name is Michelle Shake, and I'm a senior at Arizona College Prep Erie and Chandler, and I will be presenting to you a novel way to treat burn wound infections using flavonoids, exploring the interaction between flavonoids and antibiotics. Before I begin, everyone can see me, right? Hopefully. I would like to introduce the story of two-year-old Alia. Alia was a child living amid the Syrian civil war when her neighborhood was bombed, resulting in her suffering second-degree burn wounds. Despite the poor hospital and healthcare system in Syria, Alia was recovering until her burn wounds were infected with Staphylococcus aureus. Doctors didn't have the necessary antibiotics on hand, which caused Alia to pass away from an easily treatable burn wound bacterial infection. Burn wound bacterial infection is a complicated, multifaceted issue, as weak drug supply chains prevent underdeveloped countries from accessing the necessary antibiotics to treat burn wound bacterial infections. With the added challenge of antibiotic-resistant burn wound bacterial infections, prolonging hospital stays and increasing patient mortality. This project aims to provide a sustainable and effective antibiotic alternative and resistance-modifying agent through the use of flavonoids. To give context, a resistance-modifying agent is a substance that works in conjunction with antibiotics to increase the efficiency of antibiotics, so a synergistic interaction between the two components. So flavonoids are a group of phytochemicals found in a wide variety of fruits and vegetables that possess antibacterial activity. The flavonoids which I focused on were quercetin, rutin, and hesperidin, as they are incredibly accessible. Quercetin is in spinach, rutin is in apples, and hesperidin is in oranges. So from this point on in my presentation, when I refer to flavonoids, I mean the combination of quercetin, rutin, and hesperidin. To determine if flavonoids in combination with antibiotics would increase antibacterial activity, I completed 2 experiments. The first experiment I conducted was the Kirby-Bauer disc diffusion, which is one of the most widely used antimicrobial susceptibility tests. Basically, for this experiment, I had to create solutions of 3 different types of groups. So flavonoids alone, flavonoids plus amoxicillin, and amoxicillin at varying concentrations. Then I would soak an antibiotic disc, so a small paper disc, in each of the solutions, and place it on a petri dish that was streaked with E. coli. I would then incubate my finished plates after 24 hours. I would take the diameter of the zone of inhibition. So the zone of inhibition is a clear area where bacteria has been inhibited. My goal is to have a zone of inhibition exceeding 16 millimeters because that dictates based on the Johnson & Case bacterial analysis, which provides guidelines for what is a significant zone of inhibition that therapeutic would be successful. So if my flavonoids plus amoxicillin group exceeds 16 millimeters on its zone of inhibition, then it would be considered a successful therapeutic. The next test I conducted was an antimicrobial synergy test, which is conducted by utilizing a well plate which has a small amount of E. coli and LB Miller broth in each well. And essentially the concentration of flavonoid increases as you go left to right, and the concentration of amoxicillin increases as you go from up to down. So therefore you can see the 2 components working together. Then I would measure the cell density of each well plate and would ideally want the cell density to be 0. And the cell density is measured using a nanodrop. My results for the first test, the Johnson & Case bacterial analysis test, which is displayed on the bar graph I have, found that flavonoids plus amoxicillin exceeds the 16 millimeter expectations at all concentrations and has a high likelihood of therapeutic success. As you can see on the graph, the flavonoids plus amoxicillin group outperformed flavonoids alone and amoxicillin alone at all its different concentrations, which means it could be potentially successful. And the next test, the antimicrobial synergy test, found that when flavonoids were used at even a low concentration of amoxicillin, the cell density would be 0 or close to 0, which is ideal. These results are relevant and significant as flavonoids can be used as a resistance-modifying agent, which can be used to prolong the life and efficiency of antibiotics against multi-drug resistant organisms and burn wound bacterial infections and provide children like Alia a life-saving alternative. Additionally, I like to break down my significance into 3 phrases. Flavonoids are affordable, as they cost a fraction of the cost of traditional antibiotics and a fraction of the cost of producing new antibiotics. Available, flavonoids are available in some of the most common plants worldwide, such as spinach, apples, and oranges, and possess antibiotic activity, as shown by my 2 procedures. Thank you so much for your time.
Thank you again. I think probably by far our students are doing better than any of the adults in terms of staying on time in the past. That's laughing about that too, right? Thank you for that. That overview was awesome. And so our final student is Xenia Zhao from Hamilton High School. We'll share a project titled Rethinking Food Waste, Optimizing the Food Bank Supply Chain to Tackle Food Waste and Food Insecurity.
Hi, everyone. So yeah, I'm Xenia Zhao. Thank you. And my project was Rethinking Food Waste. And the purpose of this was to find an optimal location for an additional food bank in Arizona by considering both supply and demand. So I got the inspiration for my problem when I saw during the COVID pandemic on the news, farmers forced to dump their milk into rivers and plow their crops underground. And at the same time, the number of people who struggled with food insecurity ballooned in the US as they lost their jobs. And so the goal of food banks is to bridge this gap between supply and demand. If you see in the first box where you have food banks in the center, this is the food bank supply chain where you have donors on the left supplying food waste, edible food waste, and on the right you have food pantries which work directly with the people. And so I considered 3 potential locations in the northern Arizona region, simply because it's underserved currently, which included Prescott, Flagstaff, and Lake Havasu City. So I contacted Feeding America as well as the US EPA. Feeding America maintains the nation's largest database on food insecurity statistics, and the US EPA maintains an extensive database on food waste sources, their geographic locations, and identifying information about them. So I plotted the sources of food waste and generated a Voronoi diagram, which determines the jurisdiction of each food bank. And I found total weighted distance, total food waste averted, and total number of people served by food banks for each of the 4 situations of status quo, Prescott, Flagstaff, and Lake Havasu City. And after considering factors such as fuel costs, wages, and carbon emissions associated with transportation, carbon and methane emissions due to decomposing food waste in landfills, and healthcare costs due to food insecurity, I found that Flagstaff was the best location for an additional food bank. If we were to implement a new facility in Flagstaff, we could serve more than 14,000 more people than we do currently and reduce food waste by more than 5,000 tons. And I hope that this geographic method can be used for other regions of similar size in the future to also optimize food bank supply chains. Thank you.
Perfect. Well, that was, again, right on, actually ahead of time. I appreciate everybody's overview. They're really intriguing projects, just to hear you talk about it. So if you can, people, please just start posting questions in the chat. I have some questions just to start. And so Xenia, you talked about, having the inspiration, seeing what's happening from what was you observed with farmers and COVID. And I'm kind of curious with the other 2 student presenters, how did you come up with kind of the inspiration for your project? And what would be what would be your recommendation to other students as well? And so let's have Michelle start, and then go to Bailey, and then Xenia, if you can finish up with just how would your recommendations to other students. So Michelle, what do you think?
Thank you so much for the question. So how I got inspired to work on my project is I've been working with refugees since I was around 8th grade. I've done refugee-free health clinics. And when I was starting a club at my school, I was researching medical issues about refugees, and I came across this girl's story, the one that I introduced, Alia's. And, I had no idea about, the whole other side of the world has this issue with weak drug supply chains and not having access to antibiotics. So as a student who lives in a good house, has access to antibiotics, it was really eye-opening. And that's kind of what kind of was the peak for me to get into science and start working on something like this, because I saw that there's this whole other population that just isn't being addressed and doesn't have access to anything that they can use for burn wound bacterial infections. And what I would say for students is, start, looking through what your own passions are, because often like what we're interested in is what we can make out of a project. My passion was working with refugees, and it definitely led me to this idea. So for other student researchers, I would definitely suggest like looking it within your own passions is what I would do. Thank you.
Got it. How about you, Bailey?
All right, so my project came from the inspiration of I'd always had kind of an interest in permeability, particularly how it can affect antibiotic resistance. I did a lot of research on it, just getting into a rabbit hole of just text and reading. However, when I came to this year and learning this year all things, it came from my passion for mathematics, because I had recently learned calculus, and to me, it became my absolute passion. I call it magic math, and my teacher is simply amazing, inspired me to just absolutely love it and dive all the way into it. And I thought, what if I could combine this into this factor in biology? Because a lot of factors in biology are not measured in such a quantifiable way. And so applying mathematics to those factors would be something to me that is very novel and new and intensely interesting for me personally. And so I wanted to dive into that. And so I spent hours working on this, and I enjoyed every minute of it just because it's what I love doing. And I agree with what Michelle said, that whatever you do, do it what you love doing, whatever you happen to go into. If it's mathematics, if it's refugees, if it's anything, just do what you love and it won't feel like work anymore. And that's pretty much what I have to say.
Right. And how about you, Zania? Any recommendations for students in terms of coming up with that inspiration?
Yeah, I want to echo both what Michelle and Bailey said. Definitely follow your curiosity, but also a lot of students might be like scared that like what they might be interested in might not make for a good project. But I would encourage people to always try to delve deeper into their topic, because there's always science behind everything. And even if you fail a few times, you have to fail before you find like a success, as cliche as it sounds. But you just have to try as many times as possible and you'll figure it out.
So I had a question just as a, kind of doing research myself and kind of thinking about how, I don't know if it's a pressure, but, about the idea of kind of being novel and really progressing knowledge. And, one of the things that I had to learn quite a while, like being, undergrad going into grad school, was going through journals and searching and really doing a lot of time to figure out where are we progressing the field. And this was me as a, graduate student at that level. How do you, grapple with, coming up with an idea and then really knowing if it's novel, does it have to be novel? Is that a pressure to be novel? And how do you actually find that information with not just what you're doing, but potentially the thousands of other students that have done science fair projects as well?
What I think is that, there definitely is a little bit of this thing, like I have to create something new. I have to create something that's never been done before. I do believe that there is that pressure there, especially when you look at everyone else's projects. It's equally amazing. But specifically for me, when I was going through and researching and reading, what I found, a little bit overwhelming is the fact that there's so many different things going on in all these different fields of science. So really going in and collecting like what I think I can understand on a student researcher's level kind of took that away from that pressure away from me. Like focusing on what I can understand and what I can do as a student and realistically approach is definitely what kind of helped me combat that sort of like, I have to create something new, I have to do this. And out of that, I was able to find like, oh, what I am researching is something new and something that potentially could be considered novel. But, even building on other people's studies or even looking through other different ways to do something, that's also considered novel. So I really think that idea of being novel, even though that pressure is there, it's fun to kind of go up to that challenge. And even if it isn't at the end of the day, you're still broadening the field of science. So I think that's like one way that I definitely overcame that pressure. Thank you for the question.
I think that when it comes to finding something novel, finding something new that hasn't been done before, especially in the field of engineering or in mathematics, I was trying to find something entirely new like that. When it comes down to it, it's about understanding that even if you don't find it, you have still found something. Like Thomas Edison said, even if he didn't make the light bulb work like something like 1,000 times, but he still found 1,000 ways it did not work. And if you find ways it didn't work, you still learned something, and you still contributed to the overall space of scientific knowledge. And I think that even if your ideas are very ambitious, like my idea, I think it was a pretty ambitious idea. It was something that I didn't think I could actually do it at first. However, one of my favorite quotes was shoot for the moon, and even if you do fail, you'll find yourself in the stars. And that was my philosophy towards approaching things, towards fear of failure, is that even if you don't make it all the way there, you will have found something new and something important. So that's my take on it.
Yeah, I want to echo what Bailey said. Like I said earlier, you can't be afraid of failure because all results are useful, even if they disprove a hypothesis. Then at least if when you tell the scientific community, they will know where not to go. And so you need to like read a lot of scientific articles, and it does take time, but the more you read, the more time you put in, like the more you'll get out of it. And you'll have a better understanding of the field and be able to create something that maybe by chance will be new.
Thank you. And then, so we had a question in the chat for Debbie about, advice to mentor educators in other districts and how to bring a program like Hamilton to other sites.
I'm sorry, that question was for me, correct?
Correct. Yeah.
Okay. Well, I feel like, okay. So I feel like if I were going to advise a single teacher to promote research, you can do it in any class. You can incorporate research into any class. It doesn't even have to be a STEM class. You can do research in any environment. And that gives students ownership over the topic that they choose. And it really increases engagement, and it's such a powerful tool that's underused because of focus on content, which is also very important. And then in terms of science, you can start small and grow any kind of program. I did my first research science program when I taught 7th grade in Casa Grande, and now I'm here at Hamilton. So you just have to get started. You don't have to feel like you're the expert in every topic. That's not your job as the teacher. You are a facilitator. Your job is to help students grow to be experts in their topic. And if you don't understand something they're saying, their job is to explain it to you. So that would be my advice. Don't be afraid to start small, and don't feel like you have to know everything. I certainly don't know everything. Sometimes I can't remember my own name, but you have to bring a little bit of that humility with you, because you have to accept that the students are going to know more than you do at some point in time. That's the goal, is that they know more.
So we had another question from the chat, and back to the students. So did you have an aha moment when you were doing your research?
I had several aha moments. The biggest one probably was actually finding that equation and finding how permeability was relating to the something, because that was the point where I realized, oh my gosh, I have found something new. I did it. I completed my goal that I thought was not even achievable at first. And that was a big aha. But I think the most funny one is when I was trying to create a stimulus for my experiment to apply the increased permeability, I approached that in the form of making an electroporation machine, which is a $2,000 machine, which I obviously couldn't buy, so I had to make my own. And I wasn't entirely faithful that was going to work, but I ran an experiment. My data proved that I did, in fact, that I mimicked that machine with my own design that was super cheap. And I remember I was running around the school, like screaming, like wooing, like, and I ran into the office and I was like, I did it. And it was just hopping around ecstatic. And I ran across to my mom, and then I ran to my friends, and I told everybody. And that was, for me, it's a euphoric experience.
For me, I also had, the main one I think was when I found my data, because at the beginning I knew I wanted to do something with food waste and food banks, but not a lot of data is available online. So it took a lot of researching, emailing back and forth with people, like reaching out to organizations. But once they sent it back, once I looked through the data, that was my biggest aha moment to tell me that like I can pursue this project?
For me, I felt like this whole project was an aha moment at times. My first procedure, the Kirby Bauer one, which I discussed, when I saw the plates the next day, you know, overnight, I wasn't sure if this was going to work. I had to repeat this test a few times because, you know, just with the errors of the protocol. But when I looked at it the next morning and I saw, oh my God, my therapeutic is actually working, that was like a really big aha moment when I saw all that clear area creating the zone of inhibition. And then the second one with my second test, the antimicrobial synergy test that I did, having to kind of adapt that test and do it in a way that I could perform it in the lab with the materials that I had. I wasn't sure it was going to work, but you know, as I was measuring the cell density, I kept seeing that, oh my God, it's going to zero when I add even just a little bit of flavonoid. And that was really, really exciting as a student researcher to see. It's amazing to see your ideas come to life. And I think that's something with science fair that just makes it so unique.
So as you know, one thing I was thinking, especially you know, the project on refugees, like one of the faculty with me at a School for Future Innovation and Society focuses on working with refugee, you know, populations. And, you know, this is not just him, a lot of people across, you know, ASU, U of A, and so forth, research institutions do this sort of work. Have any of you reached out or thought about reaching out to communicate your findings to some of the researchers that are in Arizona and beyond?
Yes, I'm currently in the process of trying to publish my work in a publishing magazine. I'm working with my mentor at ASU Scene on trying to get my work published so that I can be out there and contribute to others' work and hopefully continue further our work in science. So, yeah.
Yeah, especially I'm really lucky I get to work with ASU. I work in the biodesign C with my mentor, and I'm definitely interested in reaching out to other groups, especially since I'm going to go to ASU Barrett. I'm definitely looking through the different groups that have done research, and I want to see in ways which I can impact and contribute to them with my project. So that's definitely my next steps as well.
For me, I'm working alone, but I do want to get into contact with some of the Arizona's representatives, maybe Feeding America again, to see if I can like implement this model in Arizona.
Awesome. I think that looking at the chat probably exhausted a lot of the questions that I know I had, and I appreciate everybody asking those in the chat. So I'm going to turn it back over to Hope for our next step.
Sounds great. Well, thank you, Debbie, and thank you, students, for joining us today, and Beth for coordinating all this and coordinating the actual event itself. I know that this is no small undertaking, whether it was the actual event, Debbie running a classroom, and students, all the research and time you put into it. So none of those are a small feat. So thank you so much for the dedication that you have towards science and engineering. And I love that we do have four powerful women, right, doing this work as well. So that's an inspiration to a lot of people as well. We were able to post this to Facebook Live, and so I can't wait to see some of the comments and feedback we get from people watching and seeing each of you and the work that you're doing. So thanks for being an inspiration. What we're going to do now is probably like 10 minutes. We're going to jump into 2 different breakout rooms. And I have some guiding questions. So Fritz is going to lead one and Michelle is going to lead the other room. And we're just going to talk a little bit about some of the work that you're doing, and then we'll come back and debrief and wrap up. So I'm going to go ahead and open those up. And again, thank you all for joining us today. We appreciate you. Here we go.